In aircraft structures, fatigue describes the gradual weakening of material when it's repeatedly stressed, even if those stresses are lower than the material's ultimate strength. It's not an immediate break like a sudden overload, but a subtle process where tiny internal changes eventually become visible cracks. Fatigue accumulates over many flight cycles, making it a core concern for the longevity and safety of aircraft components. Aircraft don't experience constant loads. They're constantly changing. Every takeoff, climb, cruise, descent, and landing puts different stresses on wings, fuselage, and landing gear. These repeated stress cycles, called cyclic loading, make materials tire over time, in much the same way a bent paperclip finally breaks after enough back-and-forth bends. Fatigue begins at places where stress concentrates, edges of holes, notches, joints, and fastener rows, where tiny microscopic slips gradually form. Over hundreds or thousands of cycles, these microscopic slips turn into tiny cracks that slowly grow with each flight. Early crack growth is slow but steady, and catching it early is key before it becomes large and dangerous. Certain locations in aircraft structures see higher fatigue because of how loads flow through them. Rivet lines, drilled holes, notches, lugs, wing roots, and areas near engine mounts are classic fatigue hotspots. These are the areas where stress concentrations are naturally high and where inspectors focus their attention to catch early signs of fatigue damage. Fatigue doesn't wait for an accident, and inspections are our early warning system. Because fatigue cracks begin tiny and then grow, inspection programs use visual checks and advanced non-destructive testing to spot early cracks before they reach a critical size. Regular checks and well-timed inspection intervals come straight from understanding how fatigue evolves in the real operating environment. Fatigue is predictable to some degree. Engineers can calculate how many cycles a component can safely endure, but real conditions vary. That's why aircraft manufacturers and regulators define maintenance schedules and life limits based on flight cycles, hours, and stress history. So fatigued parts are repaired or replaced before damage reaches a dangerous stage. Fatigue isn't just an engineering concept, it's a maintenance reality that protects safety in service.